Hello, welcome to this flip learning on differentiating exponentials, and I'll obviously do a bit on logarithms as well. Make sure you've got your blue book, a pen, a calculator, and you're in a good place to sit down and have a listen to this for a bit. So this session we're going to look at differentiating exponentials, both ones in the form e to the x and a to the x, so anything of this form, we'll differentiate that, and we'll also differentiate ln's, and I'll prove to you why. So what I'm going to do here is I'm going to integrate, what I'm going to do now is going to differentiate each of these. So I'm going to use the chain rule. Now, you might have seen this before, but I'll recap what's going on. So if I let y equal e to the u, and u be 7x, then I can differentiate this one here, which comes out as dy by du, because I'm differentiating with respect to u, is e to the u. Remember, e to the x is special, because it differentiates to itself. The next one is du by dx, because I'm going to differentiate with respect to x. That gives me 7. Remember what the chain rule is. Dy by dx equals dy times something over du. So in here, I'm going to put du. Oh. We'll get rid of that just for someone leaning on there. And then dy by du is e to the u times by 7. So that's 7 e to the u, but you know that u is 7x, so I get that. That's my answer. What I can do, though, is the following, and this is the way I'd recommend. What you will do is differentiate the power, as you realised before, which is here, which is 7, and just times it by the front. Do not take one off the power, because x is in the power. You're not taking one off the x, so that's your answer for that one. What do you think this one is then, here? If I differentiate this power, I get 2x. And again, like I said before, leave the power the same. Differentiate the power, times it at the front, and leave the power the same. This one here is the same thing, but watch out. Watch out, because here, dy by dx, differentiate the power, stick it in brackets. You get 6x minus 1, and then it's e to whatever the power was before. Don't take one off it. So notice those brackets are important. That is definitely not the same as me writing this. Yeah, that's definitely not the same, because I've not times this here by e to the power of 3x squared minus x. So this bottom one here is wrong. Okay, so differentiate the power, times it at the front, keep the power the same. Okay, I'll pause the video here and jot example 1 down. We're going to find the equation of the tangent to the curve this, where the point x equals 0. So jot this down, pause it now, and then we'll go through it together. Okay, so the best option now is to watch me do it, and then you two have a go. So, I need the equation of a tangent to a curve. I need the x-coordinate, and I need the y-coordinate, I need the gradient. So, dy by dx. Now, I'm going to actually use the chain rule on this. Yeah, because I've got a power in a bracket. You could expand it out, and I'll show you that one in a bit. But if you drag the power down, times by the differential of the bracket, which is just e to the x, then take one off the bracket power. So remember the way we did on the chain rule. Minus e to the 2x differentiates to differentiate the power, keep the power the same. And now I'm going to sub in dy by dx when x is 0, which gives me 2 times 1 plus 1, which is 2, minus 2 times 1, which gives me 4 take 2, which gives me the gradient as 2. Now, the gradient is going to be 2, so I now need the y-coordinate. If I sub in x as 0 into here, so y equals, well, I'm going to get 1 plus 1 squared, so I get 2 squared, minus 1. So the y-coordinate is going to be 4, take 1, so y is 3. So I've got the gradient is 2, and y is 3. So my equation of a straight line is y minus y1 equals x minus x1, y minus 3, the gradient was 2, and the x-coordinate is 0. That gives me 2x That gives me y minus 3, so my answer is y equals 2x plus 3. Now the best option now is have a go yourself and write those notes up in neat. And then we're going to talk about the answer, well, the next bit, actually. There's some nicely written up answers. If that helps you go through the writing these notes down. Okay, we're now going to differentiate these, which are a little bit different. Now there's a couple of ways to do this. The best one is to remember that this is true. What is that? Well, that is x. So, I can write this here as y equals e to the ln of 2x. Now that is still the same as that. I'm now going to use my laws of indices, well, laws of log, sorry, to do this as x times ln 2. And now I can differentiate that. So dy by dx equals, now differentiate this power. Ln 2 is a constant, that's like 3x or 4x or ln 2x. So you differentiate that, you get ln 2. And then you're going to times that by 2 to the x. Now be careful. That is wrong. That will be right with the times there with the bracket. Okay? So definitely worth looking at that one. Best way, probably, and I think I see this later on, is to write like that. So either one of those answers. Next one. I'm going to write the number 2 as y equals e ln to 3 minus x. If you do what we did before, I'm going to drop the minus x down. Now, I've dropped the minus x down, and I've probably not wanted to, because, well, I can do. I can write this here as e to the x times minus ln. And then what I'm doing now is I'm going to differentiate it. So I get dy by dx equals, so drag the power down. Well, not drag the power down, differentiate the power and leave the same power the same. And then you can then, this here is this, which is this, which is this from the beginning. So this is minus ln 3 times 3 to the minus x. Now you'll notice now that the answers are getting rather similar. There is a little shortcut to what we can do. So what I say here, if I gave you this to differentiate, the differential is ln 4 times 4x. If I gave you this one here, y equals 2 to the minus x, y equals minus ln 2. 2 to minus x. So you're differentiating the power, obviously, and timesing it by the front. And sticking your ln 2 in. So I'll do number 3. This one here. You get y equals 2 times a third to the x. Well, this is where it gets tricky. I'm going to go e to the ln of it all, because that 2's there. Now the sneaky bit here is you can't actually drop the x down, because the x isn't on this power. So that's why this one's a bit hard. What I would do is, you've not done the product rule yet, but what you'll notice here is that if I write this, I get the same answer before. So when I differentiate that before, I get 2 lots of my answer. So I get minus 2 ln 3 times 3 to minus x, or however I want to write that. Okay, so there is a general form of these answers, and we'll have a go through an example together now. Okay, copy this down. We're going to prove the derivative of a kx is a kx k ln x. This is like I did before, where I had a minus here, and I ended up times it by a minus. you let y equal a to the kx, and then I'm going to do my e to e ln trick. Then drag the power down. I'd watch this, then have a go. And then I'm going to differentiate it. Now that differentiated is going to be k ln a, and then e to the, what have I got before? So I've got this bit that I wanted. K ln a is e. Now we need to show our full step here of what's going on. I'm going to now bring up kx as a power, k ln a, and then this here is a to the kx as required. So practice that, see if you can do it. If you can't do that, then you're going to struggle with the questions. So pause it, have a go at that yourself, and as a little treat, see if you can tell me what this is going to be, what the derivative of that's going to be. So pause the video, write that up, and see if you can answer the yellow question. Okay, hopefully you've got your answer written down, and you should have had that for the yellow one. So you get the 2 at the front of the ln 3. So that's a general form, which is of very much use for you. Okay, final one to show you is going to be how to differentiate a ln. Now this is quite sneaky. I'm going to start with this first one and prove it to you. I'm going to e both sides, so I get e to the y is e to the ln x. Now you notice that's e to the y equals x. I'm going to differentiate now with respect to y. Oh, that just gives me e to the y. Now I don't want dx over dy. I want dy by dx, which is the reciprocal. So what I've done now is I've basically times both sides up there and down there, but I've flipped them. This is a statement that's true. Now y, e to y, is x from here. So I get 1 over x. Now notice what's interesting about that is if you write x to the minus 1 and you want to integrate that, if you add on to the power you get 0, which doesn't work. But you know that that is going to be ln x plus c. Because what you get here is you know that that differentiates to that. So, the first one, dy by dx equals 1 over x. Now what I can do now is I can use the chain rule. I can let this here be u and do my chain rule before. You might want to pause it and try it and see if you can get the answer. I'm going to give you a generic form for the answer. Differentiate the ln, because that's what you'll end up timesing by in your chain rule. So that's 4x, and then that differentiates to 0, all over the denominator. Use a chain rule to prove that. Don't start cancelling x's, because there's no x in this term. You can't start cancelling anything down here. That's your answer. Now this one's a bit sneaky. You could differentiate this and put it over itself, which is going to be drag the power down, times by the differential of the bracket, take 1 off the power. Now you'll notice in this case, and you put it over the same, that will cancel with that, and you'll get 15 over 3x minus 1. And that's it. So you actually don't need the brackets there. Or, what we can do, and my favourite, is write this as that. Drag the power down. So if you differentiate that, you get 5 lots of the differential of this. So 5 times, well, differentiate that, keep it over itself. That gets me 15. So there's some good answers. So a ln of a function, differentiate what's in here, put it over itself. Notice there's no lns anymore, and that's due to the chain rule. If I do it on this one here, let that be u, then dy by dx equals dy over du times du over dx. Dy over du is going to be 1 over u, and then differentiate u is going to be, well, this here. And you can see that u is that, and I get that is that. So that's why that ends up working. So here's a final example for us, and then you can have a go at some yourself on a piece of paper. Now, there's a few ways of doing this. You could just differentiate each term. If you differentiate this, you get, well, differentiate the power correctly, put it over the thing you just differentiated, differentiate the power, put it over the thing you just differentiated. Well, the x squareds are going to cancel and give you 3x, and that's going to cancel there and give you 1 over x, so that's 4 over x. Other option is manipulating this. That's the same as x cubed. And I'll split the lins up. You can actually times all that together if you want as another third option. And I'm going to differentiate each thing. 3 over x plus 0 plus 1 over x. And I get 4 over x. Or alternatively, I'll do the third option. You times them together and you get this. Differentiate that. Is going to give you 28 x to 3 all over 7x to 4, and that should cancel down to 4 over x as we wanted before. So take the pick which option you want. I've done them in the opposite order. I think this is the first one where I've split everything up. This one I've just differentiated it. Or you can do option 3. Pause that. Make sure you've got the 3 examples in your book. So we're just going to make some summary notes after you've wrote them down. Here's the important slide then. Differentiating e to a function, you get f dashed e to the f of x. Differentiate a to x, you get a to the x times ln x. Don't forget though, if I stick a little k in here, then obviously I get a little k there, or just times at the front, wherever you want. Which is quite a nice way of noticing it. Okay, so you can write with the k's in if you want. The other option now, well, the last one is differentiating a ln of a function. Differentiate the function, put it over the function you just differentiated. Note there's no lns here. Pause that, make sure you got them down. That is the important bit you should get out of this lesson. So you can differentiate e's, you can differentiate exponentials, and you can differentiate lns. We're now going to have a go at some work, so make sure you have a go at these questions and bring these in with a piece of paper. So you should have a book with all the notes on, 3 examples, and this slide. Put it in a nice pretty highlight if you want. Boom, look at that, pretty. And then have a go at the exercises. Okay? I'll pause now and have a go at these to have a go at. Very similar to the ones I've done before. This one is a bit sneaky. I'd probably expand the bracket out and divide everything by e to the x. And then there's a hint here for part C and D. So have a go at 1, 2 and 3. Get a little bit trickier and you get to kind of an exam style question at the end. So pause the video here with the questions on the screen. What is there? Fair for you just to differentiate and see if you know what you're doing. If not, watch the video again, make sure you know what you're doing. Once you've done the answers, press play, and once you've done the question, press play and I'll give you the answers. So yeah, pause the video now. So here are the answers for number 1. I should get 28e to 7x. For B, should get 3tx times ln 3, or ln 3 in brackets, then times 3tx. This one gets ln a half times half tx. This one's a nice, I split that up like they've done, or you could have 5 over 5x cancels down to 1 over x. So for E, you get this answer here. You can just use the result given to you before. As for F, you just get 3tx. I'd split this up here. You could just differentiate and put it over itself if you want. This one here, just watch out for your double negative. And H, as I hinted before, I'd expand that bracket out here. That's e to the 2x. And then cancel e to x out to get that, and then differentiate it to give you that. A little bit harder ones, answers for question 2. Should get 3 to the 4x times 4 ln 3. B is here. C, a little bit sneaky, you can have that as the answer, or you can give it all in terms of ln 2. Now watch out, you add the powers, you can write this here. Let me do it properly for you. It's 2 to the 4x plus 1 times 4 ln 2. Because I've simplified that to that. Hopefully you can see what I've done there. And then finally for D, a little bit trickier, get them all as powers of 2. And you get that, and you can then differentiate each term separately if you want. You can also factorise out a ln 2 like they've done here, if you want to. And that would give you this. Could always take that out as well. 2 to the minus x. Which will give you this as 2. Well, that's 1. And that will have to be 4x. But there you go. It doesn't really matter too much which form you give it in here. And then finally 3 and 4. So 3's here. That's probably the best answer. They're giving it as roughly as a decimal, but it's probably nice as well. And number 4, you end up with the equation of the tangent at this point is going to be this. Probably times everything by 4 to give you some horrendously messy answer. So yeah, hopefully you've learnt a bit there. We can differentiate exponentials and lins now. So good work. Go back over the questions, do the ones you struggled on before, make sure you get the examples, because obviously we'll be using this in lesson, but within context.